In this section, we will understand the implementation of the character gameplay ability GA_grenade. Lyra has an inbuilt grenade ability for the character and a working grenade blueprint. We will understand the following concepts by end of this section. Gameplay ability events, ability costs and cooldown, UI widget message communication, playing an animation montage, building a grenade blueprint, gameplay effect for the grenade, gameplay queue for the grenade, team subsystem in Lyra. Search and open GA_grenade. Lyra gameplay ability is the parent class to implement our own gameplay abilities. We will use three events of gameplay abilities in this grenade ability. On pawn avatar set, on ability removed, activate ability. Open the event graph. On pawn avatar set event will be fired when the ability system is initialized with the character pawn avatar. This will be one of the first events which will be fired. So all initialization logic can be done here. Extension variable is of type UI extension. UI extension is a subsystem handle to the user interface system which can be used to control the user interface. Initially, the extension value will be false. So in the false flow, check is locally controlled. This checks if it's a single player game and returns true if the character is locally controlled. Next, check the validity of the UI extension. If true, create a widget for grenade in the user interface HUD at the HUD slot HUD.slot.extra equipment. This tag is attached to the extension point tag. Grenade cooldown widget is attached to the widget class. Also, attach the owning actor or the character to the context object who owns this gameplay ability. The register extension returns the handle to the grenade widget attached to the HUD in the specific extension point. Set this to the extension variable. On event ability removed is fired when this ability is removed from the character. Unregister the created grenade UI extension here. Event activate ability is fired each time the ability is activated. In this case, the grenade is activated using the input tags. Check ability cost and check ability cooldown are inbuilt functions in gameplay ability system. Ability cost is the value which is needed to execute an ability. For example, in a gun, magazine ammo or bullets are required to fire. In a pistol, it can be a single bullet, or in a shotgun, multiple bullets, or so on. Same applies to mana in a RPG Magic. In case of grenade, we won't use this feature here, but still calls the check ability cost. Ability cooldown is the value which gives a pause or a delay to the gameplay ability after each execution, so that the character won't repeatedly activate the ability. Back to the event graph. If both check ability cost and check ability cooldown returns true, ability is ready for execution. If true, then commit ability. Commit ability approves the ability for execution. If false, call end ability, which finishes the ability without execution. In the positive flow, after commit ability, first get the spawn location of the grenade. We will spawn the grenade just in front of the player character and a little above. So the implementation gets the actor location for the Lyra character, for which we use the function get Lyra character from actor info and get actor location. Get actor forward vector gives the forward direction of the character. Forward vector is multiplied by 5 to get a little ahead in the spawn location. Same way, get actor up vector multiplied by 25 raises the spawn location for the grenade. Add them and set the location. Next, let's get the direction of throw for the grenade. To determine the direction in which the grenade will be thrown, we will use the player camera which is right behind the player. We will do a line trace by channel to a certain fixed distance with the start location as the x direction of the player camera, which is pointing front of the camera with a little offset value, and the end location as the fixed targeting range. Line tracing can be imagined as a laser beam with a start location and a hit location of the beam where it is blocked. Camera is associated with the player controller. So get the Lyra player controller using get Lyra player controller from actor info. Get the player camera manager from this. Start trace offset is the offset for the starting location, and the default targeting range is a fixed distance set for the line tracing. Use get camera rotation and get rotation x vector to get the forward vector for the camera. Multiplied by start offset added with camera location gets the actual start location for the line tracing. The forward vector for the camera multiplied by default targeting range added with camera location gets the end location for the line trace. Include the player character in the actors to ignore while line tracing. Set a custom trace channel Lyra trace channel weapon. These custom trace channels are set in Lyra for line tracing. You can find the trace channels available in the Edit Project Settings Engine Collision. These trace channels are used to customize the collision presets for each trace on what they can hit and what they can pass through. Also, set the ignore self during tracing to true. Back to the event graph. Once the line trace is completed, break the hit result and get the distance of the trace and location where the trace ended. Now calculate the lookout rotation, which is the direction for the grenade to be thrown. If the line trace is successful, calculate the lookout rotation using the hit location. Otherwise, use the target location set to the line trace. If the distance calculated by line trace is greater than 45, then use the lookout rotation logic to set the direction of the grenade throw. Otherwise, set the player controller's current rotation as the direction. Get spawn location and get spawn direction logic are shrinked as collapsed graph to keep the blueprint neat. Next, check the has authority, which is a network function which returns true if it's a single player game or server. If true, use the spawn actor node to spawn a grenade. Grenade is separate blueprint b_grenade, which we will explore shortly. Set the location, direction and the instigator. Instigator is the character who throws the grenade or the one who holds the weapon. Set the cooldown time variable using the get cooldown time remaining function. Next, an animation montage is played for grenade throw. Finally, we will pass a message using the gameplay message subsystem with tag as ability.grenade.duration.message, and the message is the cooldown time. A struct is created for messages. In this case, the struct is Lyra interaction duration message. End the ability after this. The grenade cooldown widget in the user interface HUD listens for this message, and when received, it shows a progress animation for cooldown. We will explore this separately. There are two external features used in this gameplay ability, the grenade blueprint and the grenade cooldown widget. We will explore them next. Thank you for watching this lecture. See you in the next one. In this section, we will explore the grenade blueprint and learn how we can make weapon blueprint in Lyra. This blueprint is derived from actor. It has a static mesh component with a static mesh sm_grenade. It also has a projectile movement component. The projectile movement component gives the speed to the grenade for movement when it is thrown. The initial speed and max speed are the two fields to note down. The values given are 2500 and 2550. Now let's get into the event graph. The event begin play gets executed when the actor is spawned in the environment. The set force MIP levels to be resident node is added to give quality looks to the textures used in the Niagara VFX materials. MIP levels are used in Unreal for streaming the textures for performance reasons. Using this node for a short period of time, the textures will be rendered at their best quality. Material explosion variable holds the material instance used in Niagara VFX. This node can be ignored, can be used if needed. Next, we will make sure the character and the grenade are not blocking each other when spawned. Instigator is an inbuilt variable in actor set during spawn. It specifies the pawn owner for the actor. In this case, it is the player character. Cast it to character, and if the cast is successful, use the ignore actor when moving node twice with target as character's capsule component and actor as the grenade itself. Second time, do the reverse with target as the grenade mesh and the actor as the character's capsule component. Set the should ignore to true. Next, set up the VFX trail for the grenade. When the grenade is spawned and moving, this VFX trail will be shown in the path of the grenade. Go to the function setup VFX. Using the spawn system attached function, the Niagara particle effect is displayed. Attach the Niagara VFX in the system template. Add the mesh component of the grenade as attached to component. You can go through other settings. The spawned Niagara particle is set to the variable NS trail. In Lyra, the teams are identified by different colors, and so all the associated features have those specific colors. This feature is not very critical and will not be covered in detail. In this case, the Lyra team subsystem is used to get the instigator character's team. Find team from actor function in the Lyra team subsystem is used for this. If team ID is 1, set the team color to red or otherwise blue and pass it to the Niagara particles variable team color. Next, we will set up two timers. The first timer to detonate the grenade. Use the set timer by event function to start the timer. Time before explode value is set to 2 seconds and set as the time for the timer. Attach a create event with a custom event named detonate. Once the timer is elapsed, this event will be triggered. Also, set a timer variable as a handle to this timer. This will be later used to invalidate this timer and explode the grenade immediately if it hits an enemy character in a different team. The second timer will be fired after 0.16 seconds after spawn and attached to the event post-launch cleanup. In the post-launch cleanup event, we will re-enable the collision between the player character and the grenade. We will use the same approach we did earlier using the ignore actor when moving node with should ignore set to false this time. We will also set the projectile movement component's rotation follows velocity to true to ensure a natural movement to the grenade. In the detonate event of the grenade, first we will call a gameplay queue to display Niagara effects for fire and smoke. This is done in the gameplay queue GCN grenade detonate, which we will explore shortly. Call the execute gameplay queue on actor with target as self. Gameplay tag as gameplay queue.weapon.grenade.detonate. This tag is used to identify the gameplay queue GCN grenade detonate. Use the make gameplay queue parameters and set the location to the grenade location. This can be done by using the function getActorLocation. After the explosion, Hide the grenade using the function setHiddenInGame with target as the grenade mesh. Then deactivate the projectile movement component. Once the grenade is detonated, the grenade will cause the damage to the pawns surrounding it. Check for switch has authority. This check is made to ensure the following activities are done in server or in single player mode. Use the spear overlap actors node. This node finds all the pawns surrounding the grenade. Passing the grenade actor location to the spear position. Set the radius as 45. For the objects types enumerate, use the make array and filter pawn. This makes sure only the actors of type pawn are identified in the sphere surrounding the grenade. The out actors returns an array of pawns. If the return value is true, continue with the flow for the returned pawns. Before we start with applying the damage to the pawns returned, let us create a gameplay effect context handle. This handle will be later used to add the hit result data on the pawns and pass it to the gameplay effect. Use the make effect context function from get ability system component for the instigator and set it to the gameplay effect context handle struct variable. Next, using a for each loop, all the pawns in the array are iterated. For each of the array element, a line trace by channel is done with the start location as the grenade actor location and the end location as the pawn array element location. Also, for each of the pawn array element, create an ignore actors array with all the pawns returned, removing the pawn array element from it. This ignore array is passed into the line trace just to make sure the pawn array element is not in the line trace. The returned hit result is added to the gameplay effect context handle, which is a struct variable created earlier using the add hit result node. Now, use the apply gameplay effect to target node and pass the gameplay effect context handle. Next, set the two targets. The ability system component for the instigator, who is the player character who threw the grenade, and the ability system component of the hit pawn. The level of the gameplay effect is set based on the distance of the hit pawn from the grenade. Lastly, we have the hit event for the grenade. This event is triggered when the grenade is hit something after spawn. A check is made if the grenade hit an enemy character in a different team. This is done using the compare teams function from the Lyra team subsystem. If the function returns different teams, then clear and invalidate the detonate timer created earlier and call the detonate event directly before the timer gets elapsed, and also spawn a sound at the hit location. I will ignore the teleport section for the grenade. This section covers the events when the grenade gets into a teleporter. Thank you for watching this lecture. See you in the next one. In this section, we will explore the gameplay queue for the grenade GCN grenade detonate. This gameplay queue is derived from the parent class GCN burst. The logic for the gameplay queue is written in the overridden parent function onBurst. The onBurst function has the target and spawn results which will be used in this gameplay queue. Target is the grenade actor. This value was set when the execute gameplay queue on actor node was called in the grenade blueprint. Spawn results has all the queue elements attached to this gameplay queue. We can add the queue elements in the class defaults, details, GCN effects. Under burst particles, Niagara particle effects can be added. We can see the NS grenade explosion added here. Under burst sounds, sound effects can be added. We can see the meta sound for grenade added here. There are other effects like burst camera shake, camera lens effect, decals, which can be added here based on the scenario. The gameplay queue created earlier in the grenade blueprint, gameplay queue.weapon.grenade.detonate, is added in the gameplay queue tag section to identify this gameplay queue. Now back to the onBurst function, break the spawn results and get the Niagara VFX component array. We have added only one Niagara particle effect, so use the get for the array with index 0. Cast to Niagara component. Also cast the target to grenade actor and get the team color variable from the grenade actor. Pass the team color to the team color variable in the Niagara particle effect. This section is only needed if you are implementing a color-based customization in the Niagara particle effects for the different teams. Thank you for watching this lecture. See you in the next one. In this section, we will explore the grenade cooldown UI widget W_grenade cooldown. The grenade widget is placed in the user interface HUD. For the shooter game elimination experience, the configured HUD is W_shooter HUD layout. Go to the folder Shooter Core Content, User Interface, and open the W_shooter HUD layout. The HUD or the heads-up display user interface is the screen overlay we see during the gameplay. It has elements like the weapon gun reticle, health bar, quick bar slots, and more. You can also see the grenade cooldown widget there. Lyra is designed for multi-platform. This grenade cooldown widget is also a touch button for mobile. And when the button is touched in the mobile device, the grenade ability is activated. We won't cover this mobile feature in this section. You can see the extension point with the tag HUD.slot.extra equipment. This is the place where the grenade cooldown widget will be displayed. The extension point tag HUD.slot.extra equipment is set in the details section of the extension point underscore extra equipment. Go to the folder Shooter Core Content, Weapons, Grenade. Open the widget W_grenade cooldown. The widget has a reusable action touch button widget. It has two properties in the details section under config. Associated action is set to IA_grenade, which is the input action for the grenade. It is set here for the mobile touch action. The second property, duration message tag, specifies the tag which is used to send the cooldown duration message from the grenade gameplay ability. Action touch button is reused in other abilities like dash, which has similar functions and cooldown duration. In the case of grenade, the duration message tag is set to ability.grenade.duration.message. The logic to display the progress animation for the grenade cooldown is implemented in the action touch button widget. Go to the folder main content, UI head. Open the widget w_action_touch button. Open the event graph. The event onInitialized triggers another event listen for duration if the duration message tag is valid. The listen for duration event listens for the gameplay messages. If the grenade cooldown message is received, it plays the grenade cooldown progress animation. The play animation forward node is used to play a widget animation. In this flow, the cooldown active to inactive animation is played. You can check the available animations from the Designer tab, Animations section. And during the event tick, which is a repeated event every tick, the remaining cooldown time is calculated and the inactive to active animation is played when the cooldown is completed. You can explore the event graph further for an in-depth implementation. On a general note, Lyra uses materials throughout the UI interface code with material instance parameters manipulated from the widget to execute the material graph. Thank you for watching this lecture. See you in the next one.